I want to welcome everyone to our Q4 MLPerf Training results release. I'm super excited about this one. There's a lot of folks who've contributed to this. Of course, myself, Marisa Ahmad, who joined us relatively recently, our Director of Product Management, has been super helpful. And then Hiwat and Shreya. And I believe many of you have heard from Hiwat before in prior briefings. Shreya recently stepped up as MLPerf Training co-chair. And of course, we've got many submitting organizations who, in many respects, are the stars of the show. So this is brought to you by all of us. If we want to go to the next slide. Also, embargo reminder, everyone, there is an embargo, which I think we showed on the prior slide. So November 13th, 2024, 8 a.m. Pacific time. We are recording this meeting. We'll make the recording available to everyone through Google Drive. All right, back to the next slide. Just to level set on goals and sort of rules here. MLPerf is a complicated animal. ML is a complicated animal. The goal is, so someone asked, is it okay to have note-taking in this meeting? Realistically, I think that's probably fine. We're going to be making a video available. I feel like notes are a slightly more convenient form of video for, and so I think that's probably fine. But remember, the whole thing is under embargo. So our goal here is to spread the enlightenment and understanding of MLPerf training, the MLPerf benchmarks, our philosophy, and the results. So this is an opportunity for everyone to understand more about what MLPerf is, how it works, and use that to inform their coverage and help us educate the broader community. That's really the goal here. And so questions are encouraged, and we want to have discussion. There are, however, rules on that discussion. So in particular, the goal of MLCommons is to provide a neutral playing ground and rules. And part of that neutrality is we don't want to be making competitive comparisons here, not even implicit ones. So please, don't ask me, did A beat B? I probably won't really want to talk about that. And even implicit statements like saying you're the best is but really kind of a breach of decorum. And then the other thing to point out is that there's a few folks in here who do speak for MLPerf. Myself, our chairs, Marisa and Scott are all directly attached to the organization. Everyone else is a member company, and we're not necessarily endorsing their statements, but we are absolutely endorsing the veracity of their results. All right, next slide. So this is just a brief overview of our agenda. We're going to run through a bit about MLCommons, MLPerf, the results, the benchmark suite, and then try to have as much time for Q&A as possible. Next slide. So for everyone who's here, you should have received all of these briefing materials. The results are available in Tableau via private link. The supplementals are in Google Drive, as is the press release, and then the recording of this session will also go in that Google Drive folder. Next slide. So the goal of MLCommons is really building better AI for everyone, for the whole community, bringing together industry and academia. I like to say we've got members on 6 out of 7 continents, and I'm still hunting for someone in Antarctica because, 6 out of 7 isn't good enough. We've got over 125 members and affiliates, though, and you can see many of the logos up there on the screen. Well over 50,000, over 56,000 MLPerf results to date, and probably a bit more if you include some of the power numbers. And all of this is in the vein of making AI better for everyone by boosting speed and efficiency, accuracy, and safety of AI, right? And MLPerf directly addresses the speed and efficiency. And we have other projects that are focused sort of on accuracy and safety. And so that's really the goal of the organization. And of course, MLPerf is one of the primary vehicles for that. Next slide. So MLPerf, right, started as a collaborative project, industry and academia coming together with the following goals. Right, we want to provide, as I said, a fair and level playing field to measure ML performance. Right, when we started out, the art of measuring AI performance really resulted in non-comparable results most of the time. And MLPerf has gone a long way towards helping to create a fair and level playing field that allows comparing performance across, a very broad range of submissions, right? We see submissions ranging from 1 or 2 processors up to, over 10,000. We want our benchmarks to be useful and reflective of what people are doing. And this is really critically important, right? We're using representative workloads that we know are aligned with use cases in industry. And this results in us changing up our benchmark suite fairly often at a just tremendous pace. And we want our results to be reproducible and replicatable, right? And so sort of the idea is that as we go through and do the submission, not only is there peer review, right, but all of the artifacts are available in GitHub so that you can go and download the containers that different submitters use and attempt to reproduce them. And if you have the exact system, you should actually get the same results. And this is all in service of enabling the commercial and academic community to work together to help drive innovation. Whether it's helping set the goalposts so that we can measure new architectures against, or helping buyers understand what they should in fact be buying, what is going to produce performance for them, for the scenarios they care about. Those are all of our goals. And keeping it affordable. I won't say that MLPerf is the cheapest benchmark to run. It's a little bit, it's certainly a lot more than double clicking on an executable, but we want it to be manageable for our members so that we get as much data as possible so that we can help to drive the industry forward. And this involves a lot of trade-offs that are, maybe complicated and non-obvious. So when you look at some of the advances that people are putting forward in MLPerf, it really does advance state of the art. So when you see new submissions that might be using new forms of parallelism, right? You've got tensor parallelism, you've got data parallelism, you've got pipeline parallelism. Recently with the advent of some large language models, right, you're seeing folks in the industry start to use sequence parallelism. And that's something that will make its way in through MLPerf. And so it is a test bed for many of those techniques. And when they're proven in MLPerf, they sort of form best known methods. So that if you are in the industry, you can look at an MLPerf submission and begin adapting those techniques for your own usage so that as we drive performance forward in MLPerf, it benefits the whole industry, all the customers, everyone. All right, next slide. One of the things that's challenging about machine learning is it's truly a full stack problem when we look about all the levers that we can pull to drive performance. And what this means is this does make it a somewhat complicated benchmark, but it's important to understand that all of these factors play a role in the performance that you see. In training, you've got scale. As I mentioned, we have submissions ranging from 1 to thousands of processors. Some use accelerators, some don't. Some use different configurations, right? You have improvements in software in your compiler, better code gen, more advanced algorithms, right? You can, there's many different ways to do a matrix multiplication. Which algorithm can have a big impact on performance? You've got architecture in silicon, right? As we move to more advanced process technologies with more transistors, we get better performance, and we get new architectures that specialize and deliver more performance with those transistors. Particularly for at-scale submissions, network can play a big role, right? As you look at, networking together thousands of nodes or even hundreds of nodes, that network configuration, the topology, how they communicate over the network, all that is critically important. And even the data itself, right? One of the things that I remember seeing that I thought was incredibly cool was one of the earlier submissions for large language models sorted the data, and by sorting the data, you could get better SIMD utilization, and I think it was worth 20 or 30% performance. And of course, all of this translates into how do we get the most performance, and how do we do that in a performance efficient manner? How do we drive the power efficiency in the right direction? Ray asked, this slide doesn't have storage. For MLPerf training, storage is largely factored out of the benchmark. So it's not a major factor here. That's why MLPerf storage is a separate benchmark. And, especially today, there's a lot of attention paid to the energy usage in AI. And, I think data centers are maybe 2%-ish of global power consumption. Part of the point here is how do we deliver more performance and more capabilities to make better use of that energy? All right, next slide. Over time, MLPerf has grown tremendously. We started with MLPerf training, the original benchmark, back in 2018. And, things have blossomed into HPC. We have inference for data center and edge devices, which is typically done in Q1 and Q3. We have a mobile benchmark for smartphones, tiny for sort of IoT and embedded devices. As alluded to earlier, there's MLPerf storage, looking at the storage workload that AI poses. And, in the future, hopefully the near future, we'll have MLPerf automotive sort of focused on typically inference for automotive systems, and then ML workloads for client systems, running Windows and other desktop OSs. So, we've seen a lot of expansion in breadth over time, and at the same time, next part of the build, we've also improved the maturity of MLPerf. We've added power measurement for inference and tiny for small systems. Last year, we added power measurement for training and cloud systems, so that you could measure training for tens or hundreds or even thousands of nodes. We're getting installable applications for the mobile and client benchmarks, and all this while constantly evolving our workloads. And as we evolve those workloads, there is historical comparability that we'll get to see in a little bit. And there's other technical maturity improvements. We're looking at things like the collective minds framework that allows for replayability of MLPerf inference. So there's a lot of work that goes on, and I'm tremendously proud of everything that the community has accomplished. And it really is my pleasure to get to speak about that on behalf of the community. Next slide. All right, now we're going to dive a little bit into the training benchmark, and part of the way through, I'm going to turn it over to Hiwat, our Valiant working group co-chair. Next, just one note for those who hadn't seen it, that URL has the MLPerf Training paper. You can go read that. It sort of outlines the philosophy and goals of MLPerf Training. Next slide. So just as a recap for those who haven't been to this briefing before, MLPerf Training measures the time to train a model to a target quality metric. So the key is, how do you get the model to converge to the required quality? If it doesn't converge, you don't get a score. And so all of the results are articulated in terms of time to train, typically minutes, and sometimes a little faster in seconds. In addition, we have power measurement, and that measures the power consumed by the compute nodes as well as the interconnection network. And the power consumed by the network can be measured, and sometimes it can be estimated during the workload runtime. But so the key point here is that it is that is the real power being consumed while running the workload. All right, next slide. So this is one of my favorite graphs that I get to show you, and it's sort of, I just want to pause and walk through the graph before we do the full build out. What this is showing is, on the x-axis, we've got time, and in the y-axis is the relative performance of all of the MLPerf benchmarks. And it's all normalized to 1. This is the best score for any MLPerf benchmark in a given round, and how it compares to the first round in which that benchmark showed up. And this is all superimposed across that blue line, which is Moore's law, right? And so what you can see is the dotted lines here are the older workloads that we have phased out of MLPerf. So at this point, I think all of the workloads from our original cohort have been retired. But you can see here that the performance of many of these workloads significantly exceeded the rate of progress of Moore's law. Let's do the build out here and get our arrows up. Right, and so what you can see here is, for example, mask RCNN, the performance gain over time reached something like 10x, 9x better than Moore's law, which is a really phenomenal testimony to the benefits you see of all of those factors I outlined in the prior slide, right? That 10x comes from bigger scale, better architecture, better process technology, better compilers, in many cases, more compressed data formats that help us get more throughput. And the numbers are especially great for our original cohort, because in the first round of MLPerf, in many cases, we were still, and the industry as a whole was still working on how to scale up the training of neural networks to really large processor counts. Over time, actually, and in part driven by MLPerf, we've seen that become much more commonplace. And so we're starting to see initial benchmark submissions that are at scale in their first round. But even with this trend, we're still seeing that, MLPerf is able, our benchmark scores, the best benchmark scores are still going ahead of Moore's law by a factor of 2 in this latest round. And I think that's representing GPT-3, right, which is a large language model. So Andreas asked a question here that I implicitly answered, but I'll actually explicitly answer that. Right, so I'm going to phrase Andreas's question a little bit differently. Why does it seem like the performance is flattening out here? And a lot of that is because of this scale effect that I mentioned. in the first couple rounds of MLPerf, there was a lot, honestly, for the first couple rounds, just getting everything running was a heroic endeavor. Many of our reference models were lower quality and harder to work with. And over time, we've got better at making reference models, so they're more performant. The optimization task is less heroic because the baseline's a little bit better. And for those who don't know, in MLPerf, you start with the reference model, but can re-implement it. So very commonly, almost all submitters re-implement the reference model to allow for various optimizations that might be specific to their architecture. And that's part of being fair. That's sort of, the only way we can allow accelerators and processors that look totally different to compete on a level playing field, right? Architecturally, an NVIDIA GPU, an Intel CPU, a TPU, they all look very different. And so that re-implementation of the reference model is necessary to allow for a fair playing field. Some of that re-implementation has gotten a little bit easier as the reference model quality has improved, but some of it is also that the first submissions for many of our newer benchmarks are at scale. And what that means is then when you look at the second round, you aren't seeing the benefits of scale as submitters move from 4 to 10,000 processors. You would naturally expect a significant performance improvement. And in many cases, what we're seeing is that in the first rounds, people are submitting using large at-scale systems. And so that, I think, is a big aspect of the flattening in performance, right? So there's we're still seeing great scale, but you're not seeing the improvement because it's more front-loaded. And also our reference model quality has gone up. Does that answer the question, Andreas? Yeah, perfect. All right. Next slide. So as the head of MLPerf, this is one of my favorite moments where I get to congratulate everyone for their submissions. So we've got 17 submitting organizations this time. You can see their logos up here. I want to specifically call out FlexAI and Lambda. They're first-time submitters. And as everyone knows, the first time you submit, it can be a little bit tough. And, I want to especially salute those members for their accomplishments. And then I'd also like to call out Dell, which this is their first time submitting to MLPerf training and doing power measurement. And a big, big kudos to the team at Dell for that. Next slide. So this is the breakdown of submissions. Everything this round was in the closed division. And you can see who is available cloud, available on-prem, and preview. And I believe, Hiwat, are you taking the next slide now?
Yeah, so I can take starting from this slide.
Perfect.
All right.
All right.
Okay, so as we see in the table here, so this round we have 7 benchmarks that represent a wide range of domain and the AI landscape. So compared to last round, we have dropped 2 benchmarks, Resonate and Unit 3D. So we dropped those benchmarks to keep our benchmarks relevant with where the industry is going. So as seen in the table, we have benchmarks. We have recommendation task benchmarks using DLRM DCM v2 model. And then we also have 2 benchmark in large language model, pre-training with BERT and GPT-3 model. And in addition for that, for LLMs, we have fine-tuning task, which is a domain-specific enhancement on top of pre-training model. And for this benchmark, we have Llama 270B with LoRa fine-tuning technique. And then, so this is one of the benchmark we added last round. And then in the vision domain, we have object detection benchmark using RetinaNet model. Then we have stable diffusion V2 model-based benchmarks for benchmarking image generation. And then finally, we have graph node classification using RGOT model. And so this benchmark is also the second benchmark that was added last round. So for each of our benchmarks, we have benchmark-specific training quality matrix requirement that is shown here. Next slide. So when we look at the results in 4.1, so we got 154 performance results that are successfully submitted. And in this submission, overall across all benchmarks and submission, we saw 1.26x performance improvement in closed available compared to v4.0 6 months ago. And then we also got 2 new processors submitted under preview category. These are the Google Trillium TPU and then NVIDIA's Blackwell B200 GPU. And the second thing is we're very excited to get our second power submission by Dell. So Dell submitted on their system Power Edge XE9680 system. So we would like to congratulate Dell again for their first power submission and then MLPerf Training's second power submission. So MLPerf Power is still new, but we're very excited to get 2 submissions in 4.0 and then 4.1. And also with this, we would like to highlight the importance of training power efficiency as a key matrix in addition to training time. And so we would like to encourage submission in future rounds from our submitters. Next slide. So I think we had a slide before this for the key insight. Yeah, so, all right. So, and so the key insight we observed in this round is we have 2 key insights. The first one is generative AI training is becoming more popular. So we saw that when we look at our 3 Gen AI benchmarks, which are GPT-3, Stable Diffusion, and Llama 270B with LoRa, we saw 46% total increase in submission. And another key insight we saw is we saw quick adoption and performance gain in 2 of the new benchmarks that we added last round. So specifically for Llama 270B LoRa, we saw a 16% increase in submission and then 1.26x performance increase. And then for GNN, we saw 55% increase in the number of submissions and then 1.23 performance improvement. So this rapid adoption demonstrates that we're continuously updating our benchmarks to align with where the industry trend is going, and then we're making sure that we remain relevant and representative of the industry. And then so this is being validated by the rapid adoption of the new benchmarks from our submitters. So next slide. All right, so before we move to the questions to our submitters, when we're looking at the result, what we should keep in mind is each result offers a valuable insight, even if it's not immediately obvious. So it's always useful to compare submissions that are similar in certain ways, such as same vendor, similar scale or similar processor, and then look for a difference in area when we're comparing one result versus the other. So, but overall, some valuable insight we should look from the result is how we're scaling over time, the impact of software tuning that is software tuning in the benchmarks, the effect of new processor, new software stack, and so on. So this difference helps us to understand the performance and efficiency in a deeper way. So this is how we should be looking at the result. So so once again, I would like to congratulate all of our submitters. And with that, we can move to the questions to the submitters.